Hi, welcome to this Blender video tutorial entitled Screw. Blender provides an edit mode modeling tool called Screw. The Screw tool is a type of extrusion tool similar to the Spin tool. However, the Screw tool adds an X and Z axis translation to the Spin tool, facilitating the modeling of springs or screws or any type of shell-shaped structure. To demonstrate the Screw tool, I have a blank Blender scene with the display in front view. I will add a circle object. I'll rotate the circle object 90 degrees about the x-axis so it is facing straight on in front view. I'll then tab into edit mode. The Screw tool has some very strict requirements. First, the screw operation must be generated in front view. Second, the subobject selection must contain an open polyline. That is, it must contain an open shape consisting of at least two vertices with an interconnecting edge. The screw operation localizes this open polyline, and it uses it to calculate the translation of the screw from turn to turn. Since my circle mesh is a closed polygon, I will have to add an open polyline to the object. With the circle object selected, and while still in edit mode, I'll press the Shift-A and add a plane mesh. I'll rotate this about the x-axis 90 degrees by pressing the R key, followed by the X key, followed by 90, followed by Enter. I'll move this out to the side a bit. I'll deselect the vertices and select the two right vertices. I'll then delete them. This leaves me with a polyline consisting of two vertices with an interconnected edge. I'll scale this up a bit. I'll then place it in the center of the circle object. The screw operation does not require it to have it in this position, but it's easier to visualize what's happening. Now the distance between the two vertices of this polyline will determine the translation of the screw extrusion from turn to turn. To be more precise, it uses the difference in the two z-axis locations and the two x-axis locations to determine the translation from turn to turn. In this example, the two vertices have the same x-axis location. I'll select all of the vertices, and then I'll place my 3D cursor here to the side of the selection. Like the Spin tool, the Screw tool uses the location of the 3D cursor as the pivot axis location. I'll now press the Screw button located in the 3D Editor Viewport tool panel. Notice that the screw operation spun the selection set around the z-axis one full revolution, and it translated it upwards the length of the polyline. The controls for the Screw tool are displayed in the 3D Editor tool panel once the screw operation has been executed. By default, the operation consists of one turn and produces 9 segments. I will increase the turns to 6. I'll increase the steps to 60. This produces a nice spring-like object with a spun plane around the middle. I'll press Ctrl-Tab and go to Face Selection. I'll then deselect the faces and hold down my Alt key and select one of the plane's faces. This will select the entire loop of plane faces. I'll then press the X key and delete the edges and faces. I'll then tab out of edit mode. I have the same setup here on layer 2. I'll tab into edit mode and select the two polyline vertices. Now the screw operation also translates the extrusion along the x-axis. The amount of the x-axis translation from turn to turn is calculated by the difference in the location of the open-ended polyline vertices across the x-axis. Now here the top and bottom vertices of the polyline are at the same x-axis location. I'll rotate the polyline a bit so that the two vertices have a different x-axis location. I'll then select all of the vertices and place my 3D cursor to the right of the selection. I'll then press the screw button in the 3D Editor Viewport Tools panel. The screw operation again extrudes the selection one turn, producing 9 segments. It also translates the selection along the Z-axis by the difference in the Z location of the polyline end vertices. But here it also translates the selection along the X-axis by the difference in the X location of the polyline vertices. I'll increase the turns to 6. And I'll increase the steps to 60. This produces a nice spring-like object which is tapered, again with a spun plane in the middle. I will again go to Face Select mode, hold my Alt key down and select one of the plane's faces, which selects the whole plane loop, and then I'll delete the edges and faces, and then tab out of Edit mode. Notice the difference between the two screw operations.